All right, so we're going to learn the fundamental theorem of calculus 12.5 today. And so you've been working on these antiderivatives, and the last section is those crazy Riemann sums where you're calculating the area of each sum to get the area under a curve. So that method just, could you imagine if you had like a ton of rectangles? It would take you a really long time. Okay, so let's do it a little bit different using our fundamental theorem of calculus. So what it's telling you is you can use the antiderivative, kind of ignoring the plus c, and it says we know we're going from a number to a number, so it's an answer is a number. You can find the antiderivative and put in the top number minus the antiderivative and put in the bottom number. So we can use the idea of an antiderivative to find that area under the curve much quicker. This is the average value over a said time period. So notice we have to divide it by that change between the B and the A because we're just getting a number. So here's our graph, right? We're getting that area under the curve. If I want the average per whatever it is, I would divide by whatever it wants me to divide by, depending on, what you go from to and stuff like that. So, all right, so you have two different ideas. Main idea would be right here. So let's do a problem. Problem 1 says we're going from 2 to 6 of this function dx. So let's start with what is capital F, or our antiderivative, or the solution to an integral, right, of this function. It is going to be add 1 to the 3, so I'm going to have 8x to the 4th divided by that 4. And on the 3, I'm going to add the x back. I'm going to ignore the plus c this time. Can I simplify that? Sure. 4 goes into 8 2 times, so 2x to the 4th plus 3x. So once I'm here, I have the antiderivative, then I can put the function's values in to that antiderivative. So antiderivative value at 6 would be 6 to the 4th plus 3 times 6, right? So put 6 into the answer you just got. I'm going to use a calculator, 2,610. Well, I used a calculator on my notes. Hopefully I didn't do anything wrong. And then we put in our next value, which is 2. And again, you'd then have 2 to the 4th plus 3 times 2, and I get 38. So the final answer, the area under the curve, is going to be the top value minus the bottom value. So that is 2,610 minus 38. That's going to give me an area of 2,572. Okay, so the answer to that one is 2,572. So we start with antiderivatives, then we just put in our value. Now, antiderivatives are going to get a lot harder, so it's going to make you think about your antiderivative. Okay, so problem 2. What's the antiderivative of 2e to the x? 2e to the x. So that one's a little bit easier, but let's do it. So we know our antiderivative is just going to be 2e to the x. Oops, this should have an x. It's okay. And then let's put in the two values. So we have a 5 and we have a 0. So we would have 2e to the 5th. Oh, that's definitely a decimal. 2e to the 5th power. 296.83-ish. Keeps going. Read the problem, what you need to round at. Putting in the 0, I get 2e to the 0. Well, anything to the 0 is 1. 1 times 2 is 2. So we're going to subtract 296.83, the top one, minus the bottom. I keep pointing that out. You can have a negative answer. If the shaded area is in the negative section, you will have a negative answer. Minus 2 is going to give me to 94.83. Okay. All right. Problem 3. I'm hoping you notice you're going from 7 to 7 before you even start your antiderivative. I'm not going anywhere. There's no area. Okay. We like that problem. We don't love 4. Problem 4. Let's work on our antiderivative. Okay, this is a u substitution. So I'm looking at this, and the first thing I want to do is I don't like the square root. I want to write that with the 1/2. Plus, I don't like it on the bottom. So I'm going to rewrite this to be from 13 to 22. And I'm still having the 5. And then I'm going to bring up the x plus 3. And I'm going to write it to the negative 1/2 power. So the 1/2 is the square root. And the negative brings it upstairs, dx. I like that better. Now I can add 1. Well, I don't want to quite do that part yet. Let's do our u idea. The inside is x plus 3. Okay, so the derivative of the derivative is going to be 1 dx, right? So do the derivative of that is just 1. The 3 goes away. And so that one's pretty easy. Okay, so then I'm going to add 1 to 1/2. So I'm going to write that out. We're going to add 1 to 1/2. So we still have the 5. Boop, boop. And then now we have a u. To add 1 to the 1/2, I get 1/2. Okay, divided by that 1/2. So I'm going back to that u, and then I can put the u back in. In my math lab, it just kind of keeps this 13 to 22 like this. I want to show that. It's basically saying you still have to evaluate it. Even though you're working on that antiderivative, you still have to evaluate or solving that integral. So this is going to be put back in the u, x plus 3 to the 1/2 divided by 1/2. Okay, what is 5 divided by 1/2? It's 10. Okay, x plus 3 to the 1/2. What is a 1/2? Well, it's a square root. Oops, that's kind of an ugly square root of x plus 3 here. Both of these are fine. Don't care, but I want to show you that. Okay, now I can put in the 22 and the 13. So we will put in the value 22. We will put in the value 13. And we're going to cross our fingers and hope we get this right. This one's a 40. This one's a 50. I cheated. I got the answers from over there, right? You're just putting it in. You can use the 1/2 power or you can use the square root. 22 plus 3 is 5, though. Square root of 5, or excuse me, it's 25. 5. 20, yeah, 20 is 5. 5 times that's 50. So it's not too bad. So our answer is 50 minus 40. Okay. So the harder part is going to be doing the derivatives for sure. Okay, then we have some problems that are average. So we want to do a couple more problems, but I'm going to split this up and I am going to show you this in Desmos. I'm a little nervous to show this in class. So this is for my online. So you're my online. I don't show this until everyone has finished this homework. But the problem is I can't just show this to you at the beginning of the next, class. So it's a little bit harder. In Desmos or in your graphing calculators, you can do these integrals because they're a definite integral and they have a solution of 10. You can actually do them in either one. So let's see here. So if I click in here, I can go to functions over here in Desmos, and I have to scroll till I find the integral function. And then I'm going to tell it from 13 to 22. 22 of, always use parentheses because you have to have that d dx and everything. 5 divided by the square root of x plus 3 Okay, go over till you're on the outside, enter parenthesis, and then just type dx in there. It will actually just give you the solution. Okay, in your graphing calculator, you're gonna click, sorry, oh, I have the graphing calculator app. Oh, hold on, where's it at? It was like calculate 84. Okay, so let me clear whatever the heck I have on there. I'm gonna go over here to math, and I'm going to go down to integral. Oh, it doesn't look very pretty. Oh, it does come up. Good, good. There we go. If you have a little bit older one, you'll have to Google it because it doesn't let you type in the integral looking normal, but you can still do it. Just say, how do you enter the integral? It's like got a comma. I think it goes first number, second number. No, maybe it goes function, first number, second number. I can't remember now. So what did we say this one was? This one was 13. And then I'm going to tap up. There we go. And it goes from 22. And then I got to put the function in, which was 5 divided by, I'm going to use a parenthesis around my denominator because of the way it came up. The square root of x plus 3. X plus 3. Okay. Out. Finish that. It already has the dx. Perfect. Like that. Sweet. Okay. So you will have to do some of these problems by hand on the test because what is this called? The fundamental theorem of calculus. I'm doing you a disservice if you don't do it by hand. Some, right? Okay. So I can look at number 5 and I can put that in the calculator, know the answer, then do it by hand as well. So we are going to skip up to the ones that have the average. Okay. So this one says we're going to go from 1 to 6 of this function. So it doesn't quite give us the integral, but we can write our own integral. So this one has the word average up here. Average. So that means we need 1 over highest to the lowest. So 6 minus 1, just what you're counting by, right? You need to average by each individual one, which happens to be 5 different things. And then we're going to go, our integral will go from that 1 to 6 of this function, 8x to the third minus 16x plus 4 dx. Okay, so just for practice, again, I'm going to do this one by hand because it's pretty easy to do the antiderivative on this one. The antiderivative of this function is going to go x is to the third, 3 plus 1 is 4. So I'm going to have 8x to the fourth divided by 4 minus 16x squared divided by 2 plus 4x is going to be our antiderivative. So I can break that down to what? Okay, 2, right? 8 goes in there, 2x to the fourth plus 8x squared plus 4x. And then we're still got to put in our 2 values of 6 and 1. So put in 6. And I don't know if I did that. Okay, so 6, so 2. I don't have it on here, so I'm going to have to do it. So 6 to the fourth power plus 8 times 6 to the second power plus 4 times 6. I get 2, 6, 8, 6. Why do I have a different answer? I don't know. I don't see 2x to the fourth, so add 1. That's a square. That's a 4x. No, I don't see anything wrong. All I put in my calculator is the 2x 6 to the fourth. Oh, it's a minus here. That's what it is. This is a minus. Oops. Secondhand enter brings up your same function. I have a minus sign wrong. I was like, I don't think that's right. And then it would be minus 8/6 squared plus 4 times 6. I got 2,328. Okay, do that again, but with the 1. And I love secondhand enter on here, right? Brings up the same function. You can change all the 6's to a 1. And the answer is -2. Okay, so top 1. Now we got to bring in this part too. So it's 1 over 6 minus 1 is 5. So 1/5. And then you have to times it by the top, which is the 6, is the 2,328 minus the -2. And then we'll put that in our calculator. So 2,328 plus 2, basically, right? And then divide that by 5. I get 466. So the average per, we don't have any value on this. Average per year from 1 year to 6 years is 466. Okay, so there's another average. Let's apply this a little bit. They don't give the best examples, but let's apply this a little bit. Part A, find the average cost per unit if 400 units are produced. Average cost per unit. How did we do that before in our calculus? It's in the first chapter, chapter 9. We did the we divided each of them by x, not the derivative yet. So we did, for A, we did the average cost by taking the cost divided by x. Okay, that's how we found that. So for this one, to find the average cost, you would take and divide each thing by x. We like to break it up in calculus more than we did in algebra. We could write a big line and write an x underneath, but it doesn't help us with a lot of our shortcuts for antiderivative and stuff like that. So we can see that the x's cancel in the second term. So plus 400. There's our function. And it says 400 units. Well, we're just going to put 400 in there. So the average cost of 400 units is going to be 500,000 divided by 400. 125 plus 400 is 525. So I didn't use any calculus. If it would have said the marginal average cost, I would have done the derivative. Marginal brings in our derivative. Now it's saying find the average value of the cost over this interval. So it wants the average value of the cost over this interval. So I'm selling from 0 to 400 items. What is going to be my average cost per item? Okay, so it goes from 1 over, and then you have the 400 minus 0, integral from 0 to 400, and of the function, totally different question. Go back to the original function. Do not try to use part A, dx, okay? And then you could use the antiderivative, or we could go math, go down to, I wonder if this one, the integral, the 9th one. See this one, if you look, that one brings up the not integral. This is in my older calculator. I know I've gotten it before, but I don't want to play while I'm trying to do the video. So I'm just going to bounce into desmos and do it on there. So I'm going to go to functions, scroll till I see that integral sign. And then this one went from 0 to 400. Come on, there we go, 400. And this one, parenthesis, is 50,000 plus 400x. I mean, this one would be so easy to do by hand, but dx is that, and then we have to divide it by 400 because you have the 1 over 400 outside. So maybe I think I could go times by 1 divided by 400 out here. Yeah, 130,000. Bingo. Okay. So we can do 100 And 30,000 is our answer there. So I like that you can use the calculator on some of the questions, but honestly, you need, at this point, you need the practice of the integrals. Okay, so you have to show your work on these on the test, like, or you'll get a 0, right? Or usually I give you like part of the points for at least knowing the answer, but if you don't show the work, then I don't give you the full points. All right, this last question is another wordy one, so let's do it. A company manufacture product and research department produces the marginal cost function. So marginal always said derivative, which they labeled it with the derivative, where the derivative of the cost, the marginal cost, is in dollars and X is the number of units, which is usually how we do it. Compute the increase in cost going from the production level of 400 to 800 units per month, set up the definite integral and evaluate it. Well, this is our derivative, which these are antiderivatives, right? So we're going to go from 400 to the 800. And we're going to do that of the exact function that we have, the x. And that's what it's asking. There's no average on this one. It just says compute the increase in cost from going from 400 to whatever. So we could do this one fairly easy by hand because the antiderivative literally is just going to be 300x minus square this, divide by 2. So you'd have a 4 times 2 underneath because there was a 4 there already. Which is just 8, and then put in your 800 and your 400. So put in that 800, put in that 400. And you could pause and do that if you want. The 800 is going to give me 160,000, and the 400 gives me 100,000. Okay. So you can pause and put any, you could always slow me down if I'm too fast. Subtract those and I get 60,000. Okay, so the increase in cost going from 400 to 800 units per month is $60,000. I don't know what we're making, but yeah, 400 is, who knows what we're making, but that's going to be our increase in cost. All right, fundamental theorem of calculus. You can use your calculator. We're starting to be able to do that. But I want you to try them by hand and maybe the calculator on each problem. All right. Have a good one.